Hello, this is Matthew Person. This is my video presentation on my final project for stereo correspondence. So what's going to happen when you get my project is you're going to have this folder structure with final, and then we have these four folders. So the first one is this GT0 that does not stand for Georgia Tech. That's ground truth, and that comes from the Middlebury dataset. And so you see we have this for all the quarter size training images. And we get what is the ground truth disparity as well as what is the occlusion mask. And I use both of those in my percentage of known pixels metric calculation. So those definitely need to be there. Next we got our input images, and this again comes from the Middlebury data set. I've only been playing with the quarter size training images, but I don't see why the others won't work. So again, this comes from the Middlebury data set. We get both the left and the right images for all that. And then finally we got output images, and this is where my project will write to. So depending on what image name you select, it will dump in a PNG of both the heat map and the heat map is scaled, and then just the more grayscale disparity map that's not scaled. So for instance, if I'm here in Morticycle, I can find my energy minimization graph cut algorithms. I can see a heat map for the different tuning parameters, so I can open up this one. And that is the scaled heat map, and over here would be just the non-scaled disparity map. Okay, let's go into the code itself. So everything that you need to change is just going to be up here. There's really 5 things that you may want to tweak. The first is the pixel error. Here I'm using 0.5. So again, because this is a quarter size data set, I'm saying that if my output is greater than half a pixel away from ground truth, then I am going to say that that's bad, and I'm going to use that in my performance metric. But we can make this higher or lower. The next is IM names. These are going to be the images that you want to run through the algorithm, so you can just add more, add less. The next is P sizes, which is the window size that I use for both my stereo. For my sum of square difference calculation. Here I got 5, but you can add more, add less, and it'll just loop through all the different window sizes. And the same goes for the lambdas. The lambdas are what's used in my energy minimization algorithm for the smoothest term. Okay, then finally we got this run SSD. I would set to true. This will run that naive sum of square differences calculation. If you don't want to see it, you can just make that false. All right, jumping through the code, just some interesting points on the energy minimization. When you initialize it, you can actually give it an initial disparity map, but if not, I'm just going to make it all equal to zeros. When I build the graph, I'm doing an alpha expansion algorithm, so what I'm doing is I'm adding all the grid nodes equivalent to the shape of the picture, and I'm also adding these auxiliary nodes, which in that 2001 paper they mentioned you needed to do. The auxiliary nodes will connect pixels that have differing disparities.